Hey, just a quick follow-up video here. Um, we went through an example of, wanting to build, say, an airplane landing control system with priorities for different planes, and we did a flow chart. We wrote some code. We went through the simulator and debugged it and confirmed that it worked and so on. That's all really important when you're developing and debugging and when you're learning, especially how to do this stuff. Um, but in the end, what did we have? We had something where we could hit a stimulus arrow and then step through the code, and we saw a 0 turn into a 1 in one part of the screen, and that's not incredibly compelling if you have a large system and you want to know, does the whole thing work. That's a really kind of fine-grained way of looking at it. Now you want that fine granularity, step-by-step instruction, execution and analysis when you're debugging and developing. But once you think your code works, sometimes it's nice to be able to sort of step back and see it at a larger scale. And so, in a physical lab, what we would do is we would take a proto board and we'd take a physical PIC chip, we'd program it with our code, we'd put the board into a circuit, and we might, hook up 3 switches for these requests and 3 LEDs to these outputs. And then, power up the chip, and you could flip the switches. You could say, okay, let's flip this switch to a 1, and we'd see permission A come on. And then we'd flip this to a 1 and a 0, and we'd see permission B come on. And we'd flip all 3 switches on, and we'd see permission A come on, and so on. So since we've been online, we were online last summer, I put together a little tool to help us do this. It's a graphical simulator that will give us a view of what our code is doing. And so there's instructions elsewhere for how to get this thing up and running, but I've already got it installed on my system, so it's called picsim.jar. It's a Java file. And when you run it, it brings up a window like this. And basically, you just load in your assembled file. So if we want to look at that airplane landing system, I'm going to say load file, and go to whatever directory you built your project in. So I called it planes. And then you want to go to distribution, default, production, and you should see a .hex file, planes.x.production. And what I'm seeing here is a set of LEDs connected anywhere that we've set up output pins. So remember, we had 3 output pins for RB7, 6, and 5. So those left 3 bits of port B are outputs. Well, we've got LEDs sitting on there now. And the other bits of port B, these are inputs, right? So remember, we set up our tri-state register to make these 5 bits inputs, those 3 outputs. So we can see 5 input switches here, and our code is running, right? This program counter up here is changing really quickly now. If I slow this down, you'll see it changing, about 1 instruction per second, 12, 14, 18, 1A, 1C, 1E, 22, and it's going through our code, right? And if we looked at the disassembly listing, we could see which line of code it was on. But I'm going to go ahead and run this at full speed. And let's pretend that plane B is asking for permission. Well, that means that this bit should be turned on to a 1. And guess what? The permission output for plane B just turned on. It's a red LED. And now if plane C asks for permission, nothing changes. But if plane A comes along and asks for permission, A has highest priority. Our permission changes to say, hey, plane A gets permission now. And if we take off plane B's request, nothing changes. So now A and C are requesting, A gets priority. If we stop A from requesting, only C is requesting now, C gets permission. And if C stops asking, then nobody gets permission. So this is a nice sort of high-level view of what's going on. Now, you don't want to use this when you're debugging. Okay, when you're trying to understand what's going on, this doesn't really help because you can't really look at your other file registers and status bits and so on. But if you think your code's working, this can be a fun way to kind of like come in from outside and see more easily what's going on. And just as one other example, so like we did a lab where we built a 4-bit adder. So I've got this in a project called adder, and I can go to distribution, default, production, and load that in. Well, here's my adder code, right? And it's got output bits in port A. These 5 bits in particular show me the sum of my 2 4-bit inputs. And my inputs are RB0 through RB7. So if I flip this switch to a 1, I'm doing a 1 plus 0. If I flip this to a 1, I'm doing 1 plus 1, right? And I get an output of 2, right? This is the first number, 0, 0, 0, 1. The second number is 0, 0, 0, 1. That's 1 plus 1, and there's the output 2. If I want to do 2 plus 2, it looks like this. 2 plus 2 is 4. If I want to do 15 plus 15, I can turn all of my inputs bits on. 15 plus 15, my output is 11110. Well, that's the binary for 30. If I want to do 15 plus 1, that looks like this, and my output is 16. So, you know, once you've gone through the code, you've written it, you've flowcharted it, you've stepped through it, you've debugged it, you think it's working, now I can really quickly go through a bunch of test cases here, right? This does not take the place of using MPLab, but it's an additional step you can take, and it's kind of fun, you know, if you put in all this effort to get your code to do something. It's kind of fun to be able to see it visually instead of having to, you know, interpret ones and zeros in a display window. And this is a really fun setup to use for the traffic light, because the traffic light, you know, we have time delayed reactions where lights turn yellow and then they turn red and so on and so forth. So so that's a tool that's available, and if you're interested, I will post some information on how to find this. And you're welcome to play around with it if you like. All right, that's all. Thanks.